All right, good morning. I would like to take this opportunity to thank you for coming to class. There's only 2 people in class right now, and it is kind of disheartening, that I'm trying so hard, and I have people that can't come to class on time, and so I just want to take this opportunity to thank all of you who are giving your best effort, like me. That you're trying as hard as you can to improve your grade. And we should always, as human beings, try to be the best we can, regardless of the situation. So I just want to thank you for all of you who are working hard and continue to finish the race. So thank you so much. Those of you who are working hard, you do make it worth it for me to continue to work hard. So I appreciate that. I'm going to give the announcements right now. Someone informed me that I didn't give a due date for lesson 5.3. And so I appreciate you telling me that. It was one of the hardest sections we've done. And so, since I didn't put the due date up right away, and I did this morning, I made it due on Thursday at 9 p.m. Also, we're going to have an exam 5.3 on Monday at 8 o'clock. So anyhow, I'm going to try to, since this is one of the hardest sections, I'm going to try to limit the number of problems so that you'll have to do a few problems well. Once again, you're going to have to show your work like you would any test that we've taken in the classroom. And then finally, the last day for seniors is May 22nd. So we're kind of running out of time, but between now and then, if we can raise your grade, that would be good. And basically just help you to learn as much as possible as you continue your journey, whether it be to college or to the next level at the high school. So anyhow, I know that everything you do now, you've heard this saying, you're going to reap what you sow. And so anything you do now is only going to enhance your future experience with math. So section 5.3 it's a rough one, requiring you to know a lot of math, but I'm happy to say that lesson 5.4 is one of the easiest things we're going to do. So I may even finish the lesson early today. So in lesson 5.4, we're going to look at some more formulas, product to sum, and those product to sum formulas are on page 685 of your textbook, and we're going to do sum to product, which is the formulas on 686. And once again, I do recommend that you put these formulas on a sheet to refer to during an exam. Also, so let's look at some easy stuff here. We're going to first look at the product to sum formulas, and I'm not going to write them down, but you can see them there in your book on page 685. So the first problem is express each of the following products as the sum or difference. All right. I can't see anyone this morning. I'm talking to a blank screen here. Can someone, let me see a thumbs up if you can see the boards okay. I'm not getting a good view of the boards. So are they okay? Anyone? No? Okay, I'll just have to go with this then. All right, so basically products means multiply. So we're looking at changing products to add or subtract. So for example, if you have sine of 8x times sine of 3x, remember that you cannot touch the angles. So you can't bring out an 8 or a 3 those angles cannot be touched. So they just want us to write this product. So this is sine times sine as a sum or a difference. So if you have a product, what you want to do is look at the formula that matches this. So when you have a sine of alpha times a sine of beta, label these as alpha and beta. And you just use the formula. So it's pretty straightforward. So it's going to be 1/2 times the quantity cosine of 8x minus 3x, or alpha minus beta, minus cosine of alpha plus beta. So it'd be 8x plus 3x, and then close it. So that's it. So all you have to do is simplify it down. So this would be 1/2 times cosine of 8. These are like terms. 8x minus 3x is 5x minus cosine of 11x. So I'm not sure what kind of answer they're going to be looking for on the online exams or the online work. So it's either going to be this answer or they're going to distribute. All right, so it's going to be one of those two answers. So I'm just going to circle both. So you should know how to do both. They might be assuming that you know how to distribute. You know, if we were in the classroom, I would make you do the last answer because I'm not sure if you can distribute or not. Look at another problem. So this is cosine of 4x times cosine of x. And once again, we do have a formula that applies to this. This would be 4x would be your alpha, x would be your beta. And you just use the formula. Same thing over here. So it'd be 1/2 times the quantity sine, and this is going to be alpha plus beta. So it'd be 4x plus x plus sine of alpha minus beta. That's it. So you combine like terms. So this would be the sine of 5x, be a parenthesis, plus the sine of 3x. So those are not like terms. So the angles have to be the same. So it'd have to be theta and theta, 5x and 5x, 3x and 3x. Can't add those. Those are two totally different angles. So don't be tempted to do that. So it could be that answer that you're going to get, or you could get 1/2 sine of 5x plus 1/2 sine of 3x. So those of you who are still trying, I do expect you to do very well on this test. This test could single-handedly help your grade out. And so nothing too hard here. This is pretty simple stuff. So you have to make an effort though to do it. You know, can't be lazy attitude. I'll do some more, but it doesn't really get any harder than this. A lot different than the last lesson that was requiring a lot of work and a lot of basic math knowledge and algebra 1 knowledge. All right, so I just introduced the product to sum formulas. Now we're going to do the other formulas. And those are sum to product. And those are on page 686. So same similar stuff here. I won't write down the directions, but basically they want us to express each sum or difference as a product. I'll just write it. Express each sum or difference as a product. So in other words, now we're going to see a sum or a difference, and they want us to write it as multiplication. So now we're going to see a sum, sine of 9x plus sine of 5x. Okay, now once again, you cannot add those. Cannot mess with the angles at all. So this angle and that angle, can't touch them. This problem, this is going to be your alpha, this is going to be your beta, and now we just go backwards, basically. So we look at what formula matches this, and the formula would be 2 sine of, and now they're saying alpha plus beta. So now they took the signs off now. So now this is inside the sine. And this is divided by 2. And the other one is cosine of alpha minus beta divided by 2. So now that we've applied the formula, they by the formula have put the angles together, and they're allowing us to add them. But if we didn't have this formula, we can't do anything with that statement. That statement's just a statement. So because of the formula, it's saying that we can add the angles, but you have to divide by 2 to get the definition, and then you have to multiply everything by 2. So this turns out to be 2 sine 14x divided by 2 times cosine of, what is that, 4x divided by 2. We just worked the problem out using rules that we can apply. So we can simplify this to 7x cosine of 2x. That's it. So we wrote that sum as a product. Nice. I think I can fit another one here. So let me do that. We have cosine of 4x minus cosine of 3x. And in this problem, your 4x is going to be your alpha, and the 3x is going to be your beta. So we look for the property that goes with cosine minus cosine. And it looks like this. It's a -2 times sine of alpha plus beta. So it'd be 4x plus 3x divided by 2 times sine of alpha minus beta divided by 2. So once again, by the formula, they're allowing us to add the angles. We have to divide by 2. We also have to multiply by -2 for everything to be okay. So we have sine of, what is that, 7x over 2 times sine of 1x over 2. And like I said, don't think about adding fractions or anything. I mean, this is a sine of an angle times sine of an angle. Can't mess with the angles unless there's a property that allows us to do it. That's all we can do right there.
I have a question.
Yeah.
Why is 7x squared? Like 7x over 2 squared?
Can you say that again?
In the final answer, like, it says, is that 7x over 2 squared, or that's just something else?
No, this is a 2 in the previous problem.
Oh, okay, sorry.
That's okay. That's a 2. Sorry about that. Should look like that. So let me just reiterate. This is 4x plus 3x divided by 2 in that previous step. And this is 4x minus 3x divided by 2 in the previous step. So from here to here, you have 7x over 2, and from here to here, you have 1x over 2. Sorry about that. Can you see it now?
Yeah, thank you. I just like I got confused.
No, I get it. I remember taking classes in college, especially when the instructors they'd always say things like, okay, well, here's call that thing star. And then over here, they'd work 20 steps. And then over there, they would put double star. And it was all linked together. And it was so confusing. And so I always really try to keep my work organized, because I always resented instructors that were always skipping all over the place and not keeping things organized and blending things together. And so I get it. All right, I'm going to work one more problem. You could probably already guess it's a verify. And I'll be done with the lesson after that. So this is kind of, this is easy but lengthy. So let's take a look at it. I'm just going to erase that so I have more room. This is a verify problem. Okay, so we have cosine of 3x minus cosine of 5x divided by sine of 3x plus sine of 5x, and it equals tangent. So can't simplify anything. Cannot add those. They have different angles, cannot cancel. No. So what we can do is apply the properties. And so the first one, we're going to change it from a difference to product. And this is how we're going to do it. That is equivalent to -2 times sine of 3x plus 5x divided by 2 times sine of 3x minus 5x divided by 2. And that's only the top part. The bottom part is going to be sum to product. So it's going to be 2 sine of 3x plus 5x divided by 2. And this is cosine of 3x minus 5x divided by 2, and that all equals tangent. All right, so now we have kind of a different situation here, because this is a product, and as long as we have something that's exactly the same, the numerator and the denominator, we can cancel. So first of all, we can't cancel the negatives, but we can cancel the 2's. More importantly, before I even add those, this would be 8x divided by 2. I don't even need to do any of that, because this sine of that is the same as that, and it's part of a product. So that was really neat. I didn't even have to simplify, I just got rid of it. All right, so we're stuck with a negative. It's a -1, and I'm going to simplify this now. This is sine of, what is that? -2x over 2 divided by cosine of -2x over 2. I'm going to continue to simplify. This would be negative sine of -x over 2 divided by cosine of -x over 2. So this right here is tangent, but the question is what do we do with that negative? Because we don't want negative tangent. We want tangent. Actually, this is wrong. You can cancel the 2, so let me change this. This should be -x. Hope you guys are going to correct me on that. Cancel the 2's, right? So this would be -x and a -x on the bottom. All All right, so this is going to take us back to the even and odd identities. Let me come back over here. So you can't just say, oh, tangent is equal to tangent. You got to show me how you know that. A little more complicated than just skipping to the end now. So if we're going to do the correct math, what we want to think about is the even and odd identities. And we know that cosine of negative x, if you look at your definitions, the cosine of negative x is equivalent to positive cosine of x. And sine of negative x, if you look at the odd and even identities, it's equal to, that negative is out in front, negative sine of x, where the negative's in front. So from that is where we get sine over cosine. And from there, we can say tangent of x is equal to tangent of x. Same angle. The angle is not 3x, the angle is not 5x, the angle is not negative 2x over 2, the angle is not negative x, the angle is x, because it worked out mathematically. All right. I have not put this in the assignments yet, but it's going to be 1 through 29 odd. Actually, I'm going to assign them all so you can practice, because I do want you to get an A+ on this. These are pretty simple problems. And so this is on page 689. I'm going to assign 1 through 30 all. And I expect everyone to get 100% on this exam. All right. I'm going to turn the recorder off, but before I do, don't forget the exam 5-3 on Monday at 8 a.m. Do not forget to submit your scratch paper. I gave zeros to people who did not submit their scratch paper last Monday, and I'm also requiring a meeting with them via WebEx because I'm not going to accept late work, and I'm not accepting people that are doing the exams without the scratch paper, and I need to see the work. So I do mean what I say, and I'm over getting chances now, so I'm pretty much over that. So if you have a legitimate problem of some kind, obviously you do want to speak with me. I have a couple students right now that expect me to read their mind, and they're saying a bunch of things that are kind of broadsiding me about work and this and that. And it's always good to communicate with the instructor so that the instructor doesn't think that you're playing games and messing around. So if you are interested in truly improving your grade, you will follow my requirements. And if there's any extenuating circumstances, you are in communication with me about it. All right, I hope you guys have a good day, but I hope you're not gonna leave. It's only about 8:20 something. I do want to take questions for the test on Monday, which is a lot harder chapter from lesson 5-3. This was lesson 5-4. So 5-3. So I hope you hang around for the next 30 minutes to ask me questions. I'm going to turn the recorder off though now. So I'm going to sign off the recorder, and then I'll take questions from the class. I think that's the shortest lesson I've had, 25 minutes.